Hello, this is going to be lesson 3.5. We're going to be talking about dividing rational numbers. So let's get started. Okay, so dividing rational numbers, today's objectives are going to be, I can divide rational numbers. And the standard we're working in is 7NS2. We're going to be talking about apply and extend previous understandings of multiplication and division and of fractions to multiply and divide rational numbers. So we're going to get started with that. I will shrink myself down here. So here's my little cartoon. Is there some place I can sign up for a do not call on me list? A lot of people feel uncomfortable about division, but there is no need to feel uncomfortable. It's not as bad as it looks. Okay, let's go on. Dividing rational numbers. So the rules for dividing rational numbers are the same as they are for multiplying rational numbers. If you have a positive divided by a positive, your answer, your quotient, will be positive. If you have a negative divided by a negative, your quotient, your answer, will be positive. If you have a positive divided by a negative, your answer will be negative. If you have a negative divided by a positive, your answer will be negative. That can be summed up as same sign, your answer is positive. Different sign, your answer is negative. Okay, here's a question. A diver needs to descend to a depth of 100 feet. Descend means go down. To a depth of 100 feet below sea level. She wants to do it in 5 equal descents, so 5 equal steps down. How far should she travel in each descent? This is a division problem because you see that something is going to be divided into 5 equal parts. So let's bring our number line onto the screen here. This is an up and down number line because we're talking about sea level. Could easily be a horizontal number line doing the same thing. Remember that to the left of 0 are the negatives, to the right of 0 are the positives. On an up and down one, below 0 are the negatives, above 0 are the positives. So here's our diver. She descends to a depth of 100 feet. Here she goes. She's going down. And remember, 100 is going to be negative because it's below 0. So she went down to negative 100 feet. She wanted to do it in 5 equal parts. So she just did. So how much did she travel for each one of those equal parts? Well, we have to divide. So we're going to divide negative 100 by exactly 5. 5 goes into negative 100. Well, 2 times. Remember, our answer is going to be negative because we have different signs. We have a negative 100 and a positive 5. Answer will be negative. So 5 goes into 10 twice. Notice how I put the 2 over the 0, the first 0 here, because I'm going into 10. Okay, 2 times 5 is 10. 10 minus 10 is 0. Bring down my last 0. I can't forget that. 5 goes into 0 0 times. 5 times 0 is 0. 0 minus 0 is 0. So negative 20, or she goes in 20, she goes down 20 feet for each descent. The diver should descend 20 feet in each descent, or go negative 20 feet. Okay. Look at another one. There's our rules. Bring those up. Same sign, positive, different sign, negative. Over 5 months, Carlos wrote 5 checks for a total of $323.75 to pay for his cable TV service. His cable bill is the same amount each month. What was the change in Carlos's bank account each month to pay for cable? So we see that he wrote 5 checks. The total was $323.75. Each check was the same amount. We're going to have to divide, right? So there's our number line. See if that bottom black, there it goes, that went away. Okay, so negative $323.75 needs to be divided into 5 equal parts. There's the first month's check. There's the second month's check, and the third check, and the fourth check, and the fifth check. So we need to divide. What goes on the inside? Right, $323.25. Oops, should be 75 cents. Let's see if my answer comes out right. And I'm saying it's negative because he's writing checks. He's taking money out of his account. It's not to his benefit, it's to his detriment. And we're dividing it into 5 equal checks. Now let's see, if I've got a 25 there, it means it'd be a different answer. So let's just see. Okay, so 5 goes into 32 6 times. So 5 times 6 is 30. 32 minus 30 is 2. Bring down the 3. 5 goes into 23 4 times. 4 times 5 is 20. 23 minus 20 is 3. What's next? Yep, I'm going to bring down my, I put my decimal up there. Put the decimal right here. Then I'm going to bring down my 2. And so my answer is going to be wrong because it's not. I put 25 instead of 75. But let's pretend it was 25. So 5 goes into 32 6 times. 5 times 6 is 30. 32 minus 30 is 2. Bring down the final 5. 5 goes into 25 5 times. So 25, or 5 times 5 is 25. 25 minus 25 is 0. Each check is $64.65. Carlos wrote a check each month for $64.65. So what I just want to change here to make it all work out, this should be a 2 and this should be a 2. And then we will have the correct answer. Okie dokie. Remember, it's does McDonald's serve burgers? Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Over and over again for a long division. I would encourage you to go back and watch these slides and put it in the present mode so that you can see each step of the division step by step. Next one. Oh, it's your turn. Okay, you get to try this. Come back in a minute. Welcome back. Let's see what we're doing next here. We are talking about placement of the negative sign in quotients. You can place the negative sign on the top or on the bottom or in the front of a fraction, and it means the same thing. Let's take a look at this. So here's the negative sign in front of the 12/4, right? What is the answer to that? The answer to that is the same as putting the negative in front of the 12, which is the same as putting the negative in front of the 4. All of those mean the same thing. All of them will result in the answer of -3. Okay, let's take a look at this. What are 2 other ways to show equivalent expressions for a -14/7? 2 other ways to show equivalent fractions. Well, you could put the negative sign in front of the 14. Where else could you put the negative sign? You could put the negative sign in front of the 7. And the result will still be -2 no matter where you put the negative sign. What are 2 other ways to show equivalent expressions for -32 over -8? Be careful on this one. There's 2 negative signs now. What is the answer to that? Well, 2 negatives divided by each other, same signs, answer is going to be positive, right? So it could be 32 over 8. That's going to give you a +4. Or it could be, oh, this is tricky, the negative of -32 over 8. Why does that work? Because 32 over 8 here is going to be, so this part here, let's just look at this part. This part here is -32 divided by 8, which is going to be -4. Negative divided by a positive. but then you have this negative sign making it the opposite of what it currently is. So it's currently -4, so that sign here, this extra negative, makes it a +4. Okay, so those are two other ways to write that. All the answers will result in +4. Okay, you get a question like this. See you back in a moment. Okay, now we're going to be talking about a definition. The definition is complex fraction. What is a complex fraction? That is a fraction that has both a numerator and a denominator that is a fraction. What do I mean by that? That there on the right, over here, is a complex fraction. There is a fraction on top of a fraction, and yes, you can do that. So let's see what that means. A complex fraction is really a division problem with two fractions. It's really 7/10 divided by -1/5. So determine the sign of the answer. So we have a positive divided by a negative. So our answer is going to be what? Different signs, negative answer. So our quotient will be negative. So we know that one. So positive numerator, negative denominator, same sign equals positive, different sign equals negative. So we're going to have a negative answer, we just said. Okay, we write the complex fraction as a division equation. 7/10 divided by -1/5. That's really what this complex fraction above means. So how do I do division? Well, I use keep, change, flip to solve it. So what I mean by that is I'm going to keep 7/10 just the way it is. I'm going to change the division sign to a multiplying sign, and I'm going to flip the second fraction, which is called the reciprocal. I'm going to put the 5 on top and the -1 on the bottom. That's the reciprocal of -1/5. So let's see how that works. 7/10 stays the same. Keep, change division to multiplication, change, and then flip. That becomes -5 or 5 over -1. Doesn't matter where the negative sign is put. And now we just multiply across the top. So we're going to be multiplying 7 times 5, and then we're going to multiply across the bottom 10 times -1. So let's do that. Oh, before we multiply across the top, we can cancel, which is always a good idea, so you're not working with as big of numbers as you would have been. So I know that 5 will divide into itself once, and 5 will divide into 10 twice. So I'm going to use that 5 and divide it into both the top and the bottom. So that makes 5 divided by 5 is 1, and 10 divided by that same 5 is 2. Now when I multiply across the top, I'll already be in lowest terms. So 7 times 1, and on the bottom it's 2 times -1. So that would be 7 over 2, or -7/2. Okay, let's try another complex fraction. We have -5/8 divided by -6/7. It's really a division problem with two fractions, remember. So it's really first we determine what the answer is going to be, positive or negative. Well, we have two negatives, so the answer is going to be positive, same sign, positive answer. Negative numerator, negative denominator, same sign, positive answer. Okay. Now we're going to rewrite the complex fraction as a division equation. 5 over -8 divided by -6/7. Be careful too. The second fraction is the only one you're going to flip. The second fraction is always the bottom fraction in a complex fraction. Okay, so make sure you put them in the right order or you're going to flip the wrong fraction. The top fraction is first, the bottom fraction is second. Okay, so keep the first fraction, change the sign to multiplication, and flip to the reciprocal. the second fraction. Notice how I put the 7 on top now and the -6 on the bottom. Now I can cancel if I can, which I don't see anything that I can cancel. So I have to multiply across the top and multiply across the bottom. So that gives me 35 over 48. Remember, we said the answer was going to be positive because we were multiplying two negatives together. So the answer is positive 35 over 48. Okay, let's look at this one. Is our answer going to be positive or negative? Well, we have a positive numerator and a negative denominator. So our answer will be different signs. The answer will be negative. Correct. The answer will be negative. Rewrite the complex fraction as a division equation. 7/12 divided by, notice how I put 7/12 first, divided by -21/3. Change, flip. Keep the first fraction, 7/12. Change the division sign to multiplication and flip only the second fraction. If I flip it, the 3 goes on top, the 21 goes on the bottom. Now this is one where I can cancel in two directions. Notice how I have, just put that there for a minute. I have this and this, and let's put a different color there, it's easier to see. So I have this and this will divide into each other, and 12 and 3 will also divide into each other. So let's do that. Let's cancel. Cross off my 3 because 3 will go into 12. So 3 divided by itself is 1, and 12 divided by 3 is 4. Let's do the same with 7 and 21. 21 divided by 7 is 3, and 7 divided by itself is 1. So now I don't have to reduce at the end because I've already canceled and reduced. So now I have just 1 times 1 on top and 4 times 3 on the bottom. Remember, we already said our answer was going to be negative, so that's going to be 1/12, negative 1/12. Okay, hopefully that's making sense to you, because now you get to try it. See you back in a moment. You can always rewind, and you can always look at the slides and put it in present mode and see it step by step. I would strongly suggest that. Okay, next. More ways to show division. Okay, now we have 2.8 divided by -4. Positive and divided by a negative is going to give us a negative answer, different signs, right? So we're going to show it this way. 2.8, the top number goes on the inside, the bottom number goes on the outside. And now what do? Well, I put my decimal point in right away, and I put it right above where it currently is. Okay, make sure you put it in the right spot there. And then I say how many 4s go into 28. I pretend like the decimal isn't there after I stick it on the top there. I just pretend it's not there. 4 times 7 gives me 28. 28 minus 28 gives me 0. And my answer we said was going to be negative because they're different signs. So negative 0.7 is the answer. Yay. Okay. Let's do the next one. Negative 5.5 divided by, I think that's -5. No, 0.5. That's not a negative sign. So it's negative 5.5 divided by 0.5. So we're going to put the top number on the inside. So 5.5 goes on the inside, and 0.5 goes on the outside. Now notice that one of them is negative, right? So that means our answer is going to be negative. So how do we do this? Well, our first step is to get this decimal here. Let me find my little thing here. This decimal here has got to move before we can divide. So this has to actually move right here. Get it to the way right side. If I move this one spot, I have to move this decimal one spot. And my decimal is now going to be right here. And that's where I'm going to put it, up here, right there. And I think I have the computer doing it, so let's let the computer do it. So we move the decimal one place to the right. We do the same with the inside number. One place to the right, and then we're going to stick the decimal right up on top there right away. And now we just divide as if the decimal isn't there. So it's just 5 divided by 55. So 5 will go into the first 5 once. So 5 times 1 is 5. 5 minus 5 is 0. And then we're going to bring down our last 5. 5 will go into 5 one time. 1 times 5 is 5. 5 minus 5 is 0. And remember we said we have a negative answer, so it's negative 11 point, which drop the point. It's really negative 11. So if you have a whole number, you can drop the point. Because when we talk about numbers, you don't count like 1 point, 2 point, 3 point, 4 point. We just say 1, 2, 3, 4. So this answer is negative 11. Okay, you get to try one of these or two. See you back in a minute. Okay, welcome back. We're going to talk about some higher order thinking. We're going to divide 5 by 4. 5 by 4. Is your answer a rational number? What does that mean, dividing 5 by 4? Which one goes on the inside of 5 by 4? Divide 5 by 4, right? Is that a rational number? Remember, a rational number can always be written as a fraction. So can you write that as a fraction? Of course, a rational number is always written as a fraction. So this is really 5 on top divided by 4. 5 over 4. Yes, it is a rational number. So there's a couple ways of writing it. I showed you this way. 5 on the inside, 4 on the outside, but isn't that what this is? Right? And that's a fraction. Yes. Okay. This is a fraction, a ratio of 2 integers. So this is a rational number. The number is rational by definition. Okay, I'll come back on. So your homework for lesson 3.5 is on Google Classroom, and we will see you next time. Have a great day. Bye.